Welcome to this solution video. If you like this video, please share with your friends and subscribe to Math United. Let's get started with question number 1. On the axis below, sketch the graph of this, and they are y equal to 4 x minus 1 and y equal to 3x minus 2. Okay, so to draw them, we should first assume or see how the y equal to 3x plus 2 looks like. Y equal to 3x plus 2 without absolute sign. How does it look like? So if I draw a line like this, 2 is the y-intercept, yeah, so 1, 2. So the graph will pass through this, and the gradient is 3, y equal to mx plus c, so 3 is the gradient, right? That means rise over run is the gradient. So 3 is rise and 1 is run. So how can I draw a graph where the rise is 3 and run is 1? There are two ways. I can rise 3, 1, 2, 3 and run 1, positive 1 in this direction. This was the first point from where I started. I finished here and I can join them and I get the graph. Here's the graph. Okay, that means it is crossing x-axis somewhere on negative side. Okay, so when we put absolute, the negative side reflects back and we get a reflection of this, and this V shape is the graph of y equal to absolute 3x plus 2, and we erase the negative part. This is how the graph looks like. Now the question is, where does it cross this x-axis? To find that, we can do what? We can equate the contents of this particular absolute equal to 0. That will give us the vertex, because that is x-intercept, right? When y is 0, that gives you x-intercept. So 3x equal to minus 2, x equal to minus 2 over 3. So this particular point is minus 2 over 3, and we got our graph for this one. What are they saying? Just draw them. So I am drawing it, stating the intercept with the axis. So I know that minus 3 over 2 is somewhere here and 2 will be somewhere here. So I'll just draw it like this, and from here this. So I will label the axis now. This was minus 2 over 3 and this is 2, and I will leave this one for you to do. I'm drawing it, but I'll pause the video. You will see the graph of this one, and I would like you to do it. And here is the graph. The x-intercept of that graph is 1, because if I put x minus 1 equal to 0, it gives me x equal to 1. And 4x, if I multiply this 4 with x, 4x is the gradient. Its y-intercept would be minus 4. 4 multiplied by minus 1 is minus 4. That would be down there, but if it is reflected, it goes to the plus 4, because we can't have a negative with the absolute equation of a function. So this is how the graph will look like. Let's move on to the second part of this. Solve the inequality. And what is that inequality? That the first absolute is less than the second one. So where is this red graph? Lower than. Less than means lower than 3x plus 2, that graph. So it is lower here, yeah? So it starts from here. We don't know what is this point. And it remains lower till this point. Suppose this goes beyond this, and second point is somewhere here. Between this and this x value, this could be x1 and this could be x2. Between these two x values, the graph is lower than the yellow graph, the red one. Okay, and we have to find these 2 points. To find those 2 points, we should first do what? Get rid of these absolutes. For that, we square both sides. Let's square both sides, because When we square something, even if it is negative, it becomes positive, and that's what we want, positive always. So 4x minus 1 square. So I remove that absolute and put a bracket in place of it. Less than equal to 3x plus 2 square. And since we want these points, we can get rid of the equal sign and just write equal so that we get the roots only. Okay, so let me do this one. What does this become? 16x minus 1 square is equal to, and I can open this one with this identity. A plus b whole square is a square plus b square plus 2ab. Yeah, so a square means 3x square plus 2 square plus 2 times 3x times 2. Okay, and I will expand this one also. So it becomes what? 16 x square plus 1 square, but this time we have minus, so we'll write minus 2ab, 2 times x times 1. What does it become? 9x square plus 4 plus how much is that? 4 times 3, 12x. All right. So if I open this one, it becomes 16x square plus 16 minus 32x equal to 9x square plus 4 plus 12x. Bring everything to the left side. 16x square minus 9x square minus 12x minus 32x plus 16 minus 4 equal to 0. This will give us roots now. 7x square minus 44x plus 12 equal to 0. So now I can find the roots of this by quadratic formula or splitting the middle term. I'll prefer splitting the middle term, because 7 times 12 is 84, and 42 times 2 is also 84, and 42 plus 2 is 44. So that works. 7x square minus 42x minus 2x plus 12 equal to 0. So I have splitted the middle term into two parts. Still the expression is same, but look is different. So what is common in these two? 7x x minus 6 minus 2x minus 6 equal to 0. So x minus 6 is common. 7x minus 2 equal to 0. This gives me either x minus 6 is equal to 0 or 7x minus 2 equal to 0, because they are the ones which will give a 0 if multiplied. So this gives me x equal to 6. This gives me 7x equal to 2, which is x is equal to 2 over 7. So we got two roots, and that's what we were looking for. The two roots where they're crossing. One here, the one here is the lower one of the two, which is 2 over 7, and the bigger one is 6. Very, very evident. And we know that the red graph is below yellow graph between these two numbers, and that will become our solution. So our solution is 2/7 is less than equal to, in question we have less than equal to, so we'll write that x is less than equal to 6, which means x lies between 6 and 2/7, where this inequality is valid. Next question, number 2. It says that the diagram shows a curve of this one from minus 180, you can see minus 180 here, to plus 180, which is here. Okay, what do we need to do? We have to find a, b, c or integers. Their values are to be found out. Okay, so in this format, a is the amplitude always. Amplitude is maximum minus minimum divided by 2. Why? We want this distance from maximum to minimum, we subtract, that means we get this distance. We get this distance from maximum to minimum. And if we divide it by 2, that means we get 2 parts of amplitude. This is amplitude from middle line to bottom, and middle line to maximum is also amplitude. So that's why we divide by 2, the difference between maximum and minimum. And that's what we'll do here. What is maximum here? Maximum y, that means 3. Minus, what is minimum? Minus 7. Divide that by 2, which gives us 3 plus 7, 10, divided by 2, 5. So A is 5. What about B? B is always, if it is in degrees, 360 divided by period. And what is period? Period is the horizontal distance between 2 consecutive maxima or minima. So let's say that this is one maxima, this is another maximum. What is the distance between them? And we hardly know that because we don't know the scale here, right? So what will we do? We know one minimum here, second minimum here, so this is our period. But problem is we don't know the scale again. So what can we do? We can take one more minimum and one more minimum. We know this is 180, this is minus 180, and it has 3 periods between these two. So in this case, this specific case, period will be 180 minus 180 divided by 3. In this case only, otherwise if we have a scale, we'll just take the distance between 2 consecutive minima. So it is 360 divided by 3, which is 120. But now we wanted B, not the period. So B will be 360 divided by 120, which is 3. So B comes out to be 3. What about C? C is the midline, the axis, mid value, whatever you call it. This, whatever y value is this, that's the C part always. And since it's the mid value, that means it is the average, mean of the maximum and minimum. Whatever is the average number, which means maximum plus minimum divided by 2. That's how mean is found out, right, of two numbers. So in this case, it is 3 plus minus 7 divided by 2, which is minus 4 divided by 2, minus 2. So C comes out to be minus 2. We got all A, B, and C. A point A has coordinates minus 3, 6. If I assume there is an invisible Cartesian plane here, minus 3 will be on the left side x and 6 will be here. So let me say here minus 3 and 6. 7 is positive and minus 8. 7 will be positive here and minus 8 will be here. So somewhere here we have 7 minus 8. Why am I not drawing the axis? So that the drawing is very clean. That's why. Okay, so that's the line between A and B. Given that the line AB is the diameter of a circle, so we have a circle out of this. So that means we need to draw a circle like this, okay? And we need to find the equation of that circle. What is the equation of the circle? X minus A square plus y minus b square equal to radius square, basically Pythagorean theorem. If I say this is the center, this is radius, so the distance formula will be the coordinates of this minus coordinates of this, and that will give us the radius, okay? And that's what it will be. So do we know? Okay, we know the diameter. They said it's a diameter, right? So we can find the radius. So first let's find the diameter AB. What will be its magnitude? It will be, the distance formula is x2 minus x1 square plus y2 minus y1 square. So in this case, x2, let's say this is x2 minus 8. So minus 8 minus 6 square plus 7 minus minus 3 square. So that comes to 14. 8 plus 6, 14. 14 square is 196 plus 10, which is 100. Square of 10 will be 100. So square root 296 is the diameter. What about the radius? Radius will be the half of this. So 296 divided by 2. I know this can be simplified, but I'm not interested because in this is square, we will get rid of this particular square root and everything will be okay. So I'm not bothered. What I need the coordinates of this, which are A and B. A and B are always the coordinates of the center. So the formula for mid point of two ends of a line are x1 plus x2 divided by 2 comma y1 plus y2 divided by 2. So what will be this? X1 is say minus 3 and 7. So minus 3 plus 7 divided by 2. Then we have 6 plus minus 8 divided by 2. So it comes out with positive 4 divided by 2 is 2. And 6 minus 8 will be minus 2 divided by 2 minus 1. This is the center. 2 minus 1. We have everything. We can write the equation of the circle now. X minus a square. So x minus a, we got a 2 square plus y minus minus 1 square equal to square root 296 over 2 square. And let's simplify this and we'll get our equation. Okay. This, if I expand this with the help of a minus b identities, a minus b square, which will be a square plus b square minus 2ab. So a square plus b square minus 2ab, that is the expansion of this. Then y square plus 1 square, positive 1 square, okay, because this minus and negative, two negatives will make it positive 1, and plus 2 times a and b, plus in this case because it was plus, equal to, now this is square and square root will cancel out for the numerator, but denominator will get squared because it doesn't have a square root. So 2 square is 4. All right. So x square, let me write this one first, minus 4x. Then I will write this one, which is 2y. Then I will write this, which is 4 plus 1. And 2, this will cancel out. 4 times 7 is 28, and 1 6, 4 times 4, 74. Minus 74 equal to 0. And now final answer will be x square minus 4x plus 2y. 5 minus 74 is minus 69 equal to 0 is the equation of the circle. It says the polynomial p is given by this. Okay, it has so many a's. Okay, where a is a positive integer. It is given that the 2x plus 1 is a factor. Okay, so we'll use factor theorem for this. So px, find the value of a. What is factor theorem? Factor theorem says that if the factor is 2x plus 1, right? If it is equal to 0, yeah. So suppose there is one factor, then there is another factor. It is a cubic equation. So there is third factor. If it is equal to 0, sorry, it will be equal to 0 if one of them is 0, right? And one of them is 2x plus 1. So if I make this equal to 0, the whole polynomial will be equal to 0. So what does it mean? It means 2x is equal to minus 1 and x is equal to minus half. If I plug in this minus half into this polynomial, this should be equal to 0 because one of the factors is 0. So that's what I'm going to do now. So p minus half will be a square minus half cube plus 2a minus half square plus a minus half and plus 2. This has to be equal to 0. So this becomes negative 1 over 8 if I cube it. So it becomes negative a square over 8. this will be 1 over 4 positive, so plus 2 over 4. I'm not cancelling them yet because I want these to get out together. Next, minus 1 half a plus 2 equal to 0. So it's a quadratic equation now, and this was a. Is it a? Yeah, this is also a. This is a. That means these two, it is half a and this is minus half a. So cancel out. It is 2 over 4, but it is actually half, right? So what do we get here now? A square over 8, and let me put that minus 2 to the other side so that I can cross multiply. So this 8 multiplies with minus 2, so minus a square equal to minus 16. Negative and negative cancel, then square root both sides to get rid of this square. A comes out to be plus or minus 4. But they said it's a positive integer. That means we will have to get rid of what? Negative. So we'll just write 4. A is equal to 4. Okay. Now they're saying that hence factorize px. We have to factor it. So what will we do? First we will substitute the 4 into the main equation. So our main equation becomes what? 4 square, 16x cube. Then 2 times 4, 8x square. Then this a is 4, so 4x plus 2. This becomes our actual polynomial, right? However, they said 2x plus 1 is one of the factors. That means this factor is 2x plus 1. There is one more factor, there is one more factor, and that's what we have to find out to completely factorize px. Okay, so what will we do? Let me give you an example. If I want you to find the factors of 12 and I tell you that 3 is one of the factors, what would you do to find the other factors? You will divide this 12 by this 3, and 12 divided by 3 is 4. 4 is the another factor, and 4 can be further factored into 2 into 2. So by dividing the main number by one of the factors, you get the rest of the factors. That's what I'm going to do now. I'm going to divide this polynomial by one of the factors we have, 2x plus 1. Okay, so 2x has to become 16x cubed, so we have to multiply with 8x square. Becomes 16x cubed, but we can't only multiply 2x, we have to multiply 1 also. So 8x square plus 1 is plus 8x square. And if I subtract, both change sign, both get cancelled out, gone. We are left with 4x plus 2. And 2x, if I want to make it 4x, it becomes 2. So I will 2 times 2x is 4x, 2 times 1 is 2, and this is also gone. See, completely divided, no remainder, complete factor. So we got the second factor as 8x square plus 2, but we can factor out 2 from this also. So I will write 2x plus 1 is one factor, 8x square plus 2 is another factor, and I can factor out 2 from this, so I will write 2 outside now. 2x plus 1, so this has no change, but from this I factored out 2, so what is left? If out of 8 2 is out, so 4x square is left, and 2 divided by 2 is 1. This is a positive quadratic, this cannot be factored further, so this will be the final factor of px. Do we have another question part of this? Yes, we have. Hence, show that the equation px equal to 0 has only one real root, and that root we already know. So how do we find root? Root means the x-intercept in other case. If I draw a graph of this polynomial, wherever it crosses the x-axis is called root, and at root y is 0. So that means if I make this one equal to 0, I'll get the roots. So if there are two factors, one of them is 0, right? So 2 cannot be 0, it's a constant, so it cannot be 0. 2x plus 1, it can be 0, or 4x square plus 1, it can also be 0. So this gives us 2x equal to minus 1, which I already got earlier, minus 1 over 2. This was the root. We already took it. What about this? 4x square equal to minus 1. X square equal to negative 1 over 4. And square root both sides. Negative of a square root of a negative number is not possible. So we'll have to reject this one. So we can see that it has only one real root. Write this in the form of, this means completing the square term ways where a, b, c are constants. Okay. First of all, let's talk about this b. This b is easy to find because it is equal to minus b over 2a of any quadratic expression. So minus b over 2a. So this is a for me, this is minus 2 is b, and this is c. So minus b is minus 2 over 2a. So it becomes plus 2 over 4 half. This is the x coordinate of the vertex. So since this is positive, that means this graph is opening up, right? It's concave up. So the x coordinate, we just got half, right? So since they're asking for b, and our general equation is y equal to ax minus b square plus c. But they have written plus here. That means we'll have to change the value of b here, which is minus half. So b is minus half. I'm sorry, I used b for this also, but this b is different from this b. Minus half will be the value of b. Now c is the y coordinate of the vertex. How can I find the y coordinate if I know the x coordinate? Just substitute in the main equation. So 2 half square minus 2 times half plus 3. This is how I can find y. So 2 times 1/4 is half, and this can cancel, minus 1 plus 3. That becomes what? 2 plus half, 2 and half, 5 over 2. 5 over 2 is the y coordinate, and that becomes the value of c. And now what is left? A is the one left, and a is always same as whatever is the coefficient of x square in the journal form. So a comes out to be 2. This is the best way of doing. There are other ways of completing this square, but I like this one. It is given that 2x square minus 2x plus 3 for x is less than p. Write down the greatest value of p for which f has an inverse. Mind it, they're talking about x. That means if this is half, right? So, and this is positive. So that means x-axis is somewhere down. X-axis is somewhere here, right? Now, we want a value of a greatest one so that it has an inverse. If I draw the inverse of this particular parabola, the inverse will be this way. And a function cannot have two y's for same x. Can you see it? If I find the y values of this inverse, it will have two y values which is not valid. That means I have to erase half of this particular graph. Suppose I erase this part. Okay, that means the greatest value, they're saying greatest value will be here, which is unknown, right? And I cannot write that greatest value infinity here. That means what I need to do, I have to erase the other part. So let me erase this one. And now what I've done, I have erased the lower part. That means this one will be erased, and now we have only one y value for every x, and it has an inverse. So the greatest value of x, I'm repeating, x is the x coordinate of the vertex, which is half. So p is, greatest value is half. Using this value of P, write down the range of F. So what is the range of F now? It is no change, because range of F would still be the same if it was existing the previous one. So range would be, range in this case, Y value will be, least value is 5 over 2 and it is above that. So your range will be Y is greater than or equal to 5 over 2. This is the range. Do we have more? Yes. Using this value of P, find the expression for F inverse. Now we have to find the X inverse for this, and I can find it from here. So A is 2, B is minus half square, and C is 5 over 2. So I need to find inverse of this, and let's make it to equal to y here. And since we have to write inverse, in inverse we interchange x's and y. So our inverse starts here, y becomes x, and then it is y inside this bracket plus 5 over 2. And now my target is to isolate this y. First of all, this 5 by 2 should go, so it will go to the left side, equal to 2y minus half square. Next, this 2 should go, so the other side will become half. So when this 2 goes to the other side, it becomes half and multiplies with the rest of it, cross multiply. And now this square root must go. So I'll square root this side and square root this side also. So, but here when we square root, we'll get plus and minus, but we have to decide which one we want. And if I look at my original graph here, above upside positive was y was going to be positive, x is going to be negative. So in this case, y, whose value will come on the left side, will go negative because x is going negative here. That means this plus will be ignored. And now we will cancel this square with square root, and what are we left with? Minus half x minus 5 over 2 equal to y minus half. And now to leave this y alone, minus half will go to the other side, we'll be left with minus half, and it was square root also, no? It was square root. Half x minus 5 over 2. This is equal to y, which is f inverse x. This is what they wanted. So we found the inverse. It is given that tan theta is square root 5 over 5. This is the domain, and we have to find the value of cos theta. Since domain is this and tan is positive, and if we look at the quadrants, tan is positive in third quadrant. Can you see? That means they're talking about this angle to be in third quadrant. Okay? And if I draw a triangle here, and tan theta, we see that it is opposite over adjacent. So square root 5 is opposite, and the adjacent is 5. That's what you can. It is not exactly this. That is the ratio. Right? It's called trig ratio. So this is the simplest part of this, but it will work. Now they're asking us to find cos theta. So cos theta in third quadrant is negative, isn't it? Cos is negative in this. But according to this triangle, right angle triangle, what will be the value of cos theta? Cos theta is adjacent over hypotenuse. Right? So adjacent is 5, but hypotenuse is not known to us. And we can find that hypotenuse with the help of, you guessed it right, Pythagorean theorem. So hypotenuse square will be equal to square root 5 square plus square root, not square root, 5 square. So it is 5 plus 25. H square is equal to 30 So h will be square root 30. We cannot simplify it because none of the factors is a perfect square. So square root 30, we'll leave it. Okay, so this hypotenuse comes out to be square root 30, and that's what we will use here. Minus adjacent is 5, and it is square root 30. And if you want to simplify this, you can leave your answer like this, or you can do what? 5 can be written as square root 5 times square root 5. Square root 30 can be written as square root 5 times square root 6. 5 and square root 5 cancel, and we are left with minus square root 5 over 6. If you want to rationalize the denominator, that is also okay. Okay. Now, find sine theta also. So, what is sine theta? Sine theta is opposite over hypotenuse. Opposite in this case to theta is square root 5, and hypotenuse is square root 30. So that comes out to be, they will cancel out, but the square root will stay 1 over square root 6. Yeah. If square root 30 is broken again like this, it will, square root 5 will cancel, and it will be this answer. Or if you want to rationalize the denominator, it will be square root 6 divided by square root 6 multiplied. So it will be square root 6 over 6. That's sine theta. Let's see what next. Find the value of secant theta plus cot theta. Okay, so we can do secant theta. C part starts here. Secant theta is 1 over cos theta, and cot theta is 1 over tan theta. So 1 over cos theta means the reciprocal of what we have here. Cos theta we got square root 5 over square root 6 negative, and I should have written here also negative because sine is also negative in third quadrant. So it will minus square root 6 over 6. Okay. So 1 over cos theta will be square root 6 over 5 reciprocal of minus square root 5 over 6 reciprocal of that. Okay. Plus tan theta was square root 5 over 5, so it will become 5 over square root 5, the reciprocal of tan theta. Since their denominators are exactly same, we can simply add them. Square root 5 is common, so it will become 5. I will write this one first. 5 minus square root 6. And this is what they wanted. If you look at the question again, this is the format they wanted. A plus B square root C. So in this regard, A comes out to be 5. B is negative 1, and C is 6. Done. Number 7 says the diagram is of this function which is coming down, a straight line which is going up. This is the function intersecting at A. Find the coordinates of A. That means point of intersection. Whenever we want to find the point of intersection, equate, because this is y, and at this point they will have common y. Yeah, same y coordinate. So we'll equate the other parts. 5 over x plus 1 plus 2 is equal to 2x plus 1. So I equated the counterparts of y for both to find the point of intersection. Alright. So first thing first, this x plus 1 should go. So what will I do? I will multiply the whole of the equation by x plus 1. So that when this x1 plus 1 multiplies with this 5 over x plus 1 and x plus 1 cancel out, we are left with just 5. But this 2 will multiply with x plus 1, it will give us 2x plus 2. And then on the right side, 2x plus 1, whole of it will multiply with x plus 1. Alright? So now it becomes 7 plus 2x equal to 2x square. If I multiply this and this, 2x and this x and this 1. Let's bring everything to the right side so that we get a quadratic equation. So 2x square. Oh, this 2x and this 2x cancel out, so we are left with only x. And this 7 goes there, becomes minus 7. So plus 1 minus 7 will be minus 6. All are taken care of. We got this particular quadratic equation, which will give us 2 answer, obviously. So let's, because it is 0, so we'll have to factor the right side. So what will that be? 2 times 6 is 12. And 4 times 3 is also 12. So I'm splitting the middle term. 2x square plus 4x minus 3x minus 6. 4 times 3 is 12. Alright. So 2x common in these two. Not 2. Just x. X. Plus 2 minus 3 x plus 2. 0 equal to x plus 2 is common in both. So what is left? 2x minus 3. This, if I make it equal to 0 so that multiplication is 0, will give me x equal to minus 2. This gives me 2x equal to 3, which is x is equal to 3 over 2. This is positive, this is negative, and on this grid we can see that our a is on the positive side of x. That means this is our answer. This is not our answer. So what was the question? Find the coordinates, not coordinate. That means we got the x coordinate as 3 over 2. We need to find the y coordinate. To find y coordinate, I can use either this equation or this equation. Doesn't matter because both of them are valid at a. So I'll use the easier one, 2x plus 1. So y equal to 2x plus 1, 3 plus 1, 4 are the coordinates of point A. Okay. There should be a B part also, which definitely asks us the area of the shaded part. Okay. So what will I do? I'll use the other part. Let's use this part to find the area of the shaded part. This is the B part. Okay, so what will I do? I will just draw a vertical line. I know the coordinates of this. 3 over 2 is x, so that means this point is 3 over 2. Alright? And the height of this, if I look at this shape, what this shape looks like? Trapezium or trapezoid, right? So I will do what? I will find the area of this trapezoid and subtract from the area under this curve from 0 to 3 over 2. From this area under curve, I'll remove the trapezoid. So let's find the area of trapezoid first. Area of the shaded part will be area under curve minus area of trapezoid. So area of trapezoid will be half first parallel line plus second parallel times the height between those parallel lines. First parallel line is this, okay, whose y coordinate of that point was 4. So this height is 4. We do not know this, right? But what we know that this is the y-intercept of the line. What is y-intercept of this line? 1. So that means this A is 1, B is 4, this 4, half in front, and height. What is the height between these two parallel lines? 3 over 2. So it becomes what? 5 times 3, 15 over 4. This is the area of trapezoid. Okay. Now, for area under curve, we have to integrate from 0 till 3 over 2. What? The curve. Curve is 5 over x plus 1 plus 2. And when we integrate this, it has a linear denominator, so it's easy. 5 natural log x plus 1 divided by the differentiation of x plus 1, which is 1. There is no need to divide by 1. So, enough. Plus, what is the integration of 2? 2x plus c from 0 to 3 over 2. Let's plug in. 5 natural log 3 over 2 plus 1 plus 2 times 3 over 2. Let's ignore c for the time being because it will get cancelled out, so we'll just substitute 0. 5 natural log 0 plus 1, which is 1. 2 times 0, which is 0. So natural log 1 is also 0. Gone. Gone. This 2 is cancelled with this one. So 5 natural log 3 over 2 plus 1 will be 5 over 2. And plus 3. This is the area under curve. Okay. Now, to find the area of the shaded region, what do we do? You got it right. Area of the shaded region will be 5 natural log 5 over 2. This is what we decide, right? Area under curve minus area of the trapezoid, 15 over 4. Do we need, okay, so if it is exact area, we can just leave it, otherwise decimal will be the answer. 5 natural log 5 over 2, and this will be 12 minus 15, 3 over 4. This is the exact area. Number 8. The first term of a GP is 10. So first term is 10. The GP has a positive common ratio R. Okay. The first term of an AP. So this is GP. Let's write AP somewhere else. Is also 10. So let's call it A1. No, let's write U1. So I want to differentiate between the two. Okay. AP has a negative common difference. So D is less than 0. Second term of GP is the same as the fourth term of arithmetic progression. Okay, so let's interpret this one first. So what will be the U3? The second term of GP. That means A2. The formula for any term of GP is AN equal to AR n power n minus 1, right? A is 10. R is positive, they said, but 2 minus 1 will be the exponent because it's the second term. So 10R. Okay. Now here they said it is same as the fourth term. So U4 of this. So what is the formula for UN of an AP? First term plus n minus 1 D. Okay. So it will be first term 10 plus 4 minus 1 D. So it comes out to be how much? 10 plus 3D. Now they said both are equal. That means 10R is equal to 10 plus 3D. This becomes our equation number 1. Second, the third term of geometric progression here is same as the sixth term of AP. So by same method, please pause the video if you want to make the equations yourself. I'll start after 3 seconds. Okay, so A3 is equal to 10 R to the power 3 minus 1, which is 10R square. What about U? They said sixth term, right? So U6 will be 10 plus 6 minus 1 D, which is 10 plus 5D. Okay, and they said this is equal to the third term of GP, so 10R square. All right. So now I want to find one of them, and I think D is better to be eliminated in this one so that we get something here. So What should I do? I will multiply this by 3/5. Why? Because my purpose is to make this 3D so that this D is cancelled out here. So 3/5 times 10 will be 30r square. No, 6r square. Okay. 10 minus 10 will be 10 times 3/5 will be how much? 2 times 3, 6. 5 times 3/5 will be 3D. So I converted this number 2 equation by multiplying 3/5 into number 3 equation, and now I'll subtract so that D goes off. Or rather, let me subtract the upper one from the lower one so that my positive 6r square is there. So see, can you see, we can do so many things in mathematics. We can change the sign of the upper ones. We can subtract the upper one from the lower one. So this cancels out. 6 minus 10 is minus 4. And 6r square minus 10r is not possible. We cannot subtract this. So we'll just write 6r square minus 10r. It becomes a quadratic equation. So 6r square minus 10r plus 4 equal to 0. 6 times 4 is 24. 12 times 2, but there will be only one negative. So 6 and 4 again. Okay. 6r square minus 6r minus 4r plus 4. So I broke this minus 10 into two parts so that I can factorize the first two terms, which will be r minus 1, and second two terms r minus 1 equal to 0. Let's complete it here. So it comes out r minus 1 in both, so r minus 1 and then 6r minus 4 equal to 0. The multiplication of two factors is 0, that means one of them is 0, we don't know which one. This gives us r equal to 1. This gives us 4, 6r equal to 4, r equal to 4 over 6 or 2 over 3. But only one of them could be correct, and that will be this one. Why not 1 can be an answer? If r is 1, that means every term is same. Yeah? If 6 is the first term, 6 multiplied by 1, 6 multiplied by 1, 6. So there's no pattern. So 1 cannot be an r, 2/3 is the r. And what is the question? Find the values of r and d. So d we did not get. Let's find d here. So r we got 2/3, d will be what? Let's do it here. D will be, which one I should use? The simple one. This was the simple one. 10r, this one. 10r is 2 over 3. 10r equal to 10 plus 3d equal to 10 plus 3d. So 20 over 3 minus 10 equal to 3d, which comes out to be how much? Minus 30 minus 10 over 3 equal to 3d. D will be cross multiply minus 10 over 9. And they said negative, right? They said negative, it is negative. So D is minus 10 over 9. R was 2 over 3. In B part, they asked whether the geometric progression GP has sum to infinity. And what is the requirement for GP to have sum to infinity? The R should be less than 1, which is 2/3 here. So definitely it has sum to infinity. Part B is also answered. Solve this logarithmic equation. Only problem here is that the base here is 2, base here is not 2. So it would become a little difficult. But what will we do? We'll convert one of the bases into the other. And it will be a good idea to convert into base 2 because it's a number. So it will be easier, I hope, to solve. So what will I do? I'll write this as what it is. Log base 2 x plus 1. Okay. Now this is to be changed. So whenever we change one base, let's say log a base b, okay, and I want to convert it into some base, say c. So it will be log base c b, the main number remains same, but the log this thing changes, the base changes. But it can't be done. Nothing is free in this world. We have to compensate. So we compensate by dividing by the same base, which is new one, c, but this a, which was the original base, become the main number. Okay, that's what I'm going to do here. This base will be changed. So minus 4 remains what is. This becomes log base 2, because it was here log base 2, and the main number remains main number 2, but it will have a denominator now by log base 2, and the base which was there earlier, x plus 1, like base a was here and it became main number, x plus 1 will become main number, okay, equal to 3. Okay, now log base 2 is 1, isn't it? What exponent of 2 is 2? 1. So that means if you ignore this, it will be good, no problem. So now it becomes a new equation. Log base 2 x plus 1 minus 4 divided by log base 2 x plus 1 equal to 3. Now if you notice, they are exactly same. Let's assume log base 2 x plus 1 is equal to a new alphabet t. It will make our job easy, right? So t minus 4 over t is equal to 3, and I have to solve this. I'll do what? I'll multiply the whole equation by t so that this denominator goes. So t times t is t square. When minus 4 over t multiplied with t and t cancel, we are left with just minus 4 equal to 3t. And it becomes a quadratic equation. And now I'll split the middle term as usual to get the value of t. So t square, 4 times 1 is 4, so minus 4 t plus t minus 4 equal to 0. T taken common, t minus 4 plus 1 t minus 4. So we get t minus 4 t plus 1 equal to 0. So we have two solutions from here, which are t equal to 4 from this one, t equal to minus 1 from this one. But t was not the question. Question was to solve the equation which had x. So we have to go back to x. So it will be log base 2, this one, all right. Log base 2 x plus 1 is equal to 4, and second one log base 2 x plus 1 equal to minus 1, right? So if I remove log from this side, the other side becomes the power of the base. So x plus 1 equal to 4, sorry, 2 to the power 4, not 4 to the power 2. Okay, 2 to the power 4. Base remains base, huh? So x equal to 16 minus 1, which gives you x equal to 15. That is the first solution. Here, x plus 1 becomes 2 to the power minus 1. So x equal to 2 to the power minus 1 is half, and this was plus 1 minus 1. X equal to minus 1 over 2. Okay, but once we get the answers of a logarithmic equation, we should see which one works. So log base 2 x plus 1, 15 plus 1 is okay, no problem. However, if I put minus half here, so minus half plus 1 is positive half. Okay, that is also working. And can log have a half base? Yet it can have. So both are okay. Both are working. We should always check whether they are working or not, but in this case, both are working. They are the answers. The points P lie on a curve 5x plus 2 to the power 2/3. All right, P. Okay, so there's a curve and P lies on it. Okay. The x coordinate of P is 5. Okay, y coordinate. Let me find the y coordinate here. So 5 times 5 is 25 plus 2, 27. 27 to the power 2/3. I'm doing it mentally. You can use your calculator. 1/3 is 3, 3 square 9. So 5, 9 are the coordinates of P. The normal to the curve at P intersects x plus y at 11. Sorry, x plus y equal to 11 at Q. So the normal, this is tangent. This is tangent, right? So the normal will be this line, normal. It crosses another equation which is x plus y equal to 11. Let's say that is the equation. X plus y equal to 11 at Q. Okay, this is the normal. Okay, the point R is the reflection of Q in the tangent. This is the mirror line now. That is, it is on the other side here, and this is R, or the curve at P. Find the coordinates of R. So obviously, if the Q R is the reflection of Q on this mirror line, this distance has to be equal to this. That means 5, 9 will be the midpoint of Q and R. Right? Can you see? Visually, we can see that very easily. All right. So first, let's find the coordinates of Q. For coordinates of Q, we need to know the equation of QR. So for equation of QR, first we'll have to find the gradient of tangent. Gradient of tangent is nothing but dy over dx. This is the gradient of the tangent at P. So we have to differentiate the equation of the curve. This one. So 2 over 3 will come in front because it's a linear inside. So we can do that. 5x plus 2 remains what it is. But the exponent goes down by 1. 2/3 minus 1 will be minus 1/3. And further we have to multiply by the differentiation of what is inside, chain rule. What is differentiation of 5x plus 2? 5. So dy over dx is this. At x equal to 5, gradient of tangent. What will that be? That will be 2 over 3, no, 10 over 3 now. 5 multiplied by 2. 10 over 3. 5 times 5, again, 25 plus 2. 27 to the power minus 1 over 3. And it will 1 over 1 cube root of 27 is 3. And because of minus, it will become 1 over 3. So 10 over 9. 10 over 9, not 11. 10 over 9. Okay, so the gradient of this line is known. What will be the gradient of the tangent? Sorry, normal, which is 90 degree to the tangent. So the gradient of normal at, again, P, which is 5, 9, will be minus 9 over 10. Negative reciprocal of whatever is the gradient of the tangent. Now we'll find the equation of tangent. How do we find equation of tangent? Y minus y1 equal to mx minus x1, where x1 and y1 are the points on the line. Not tangent. Why did I write tangent? Normal. So 5, 9 is a point on the normal. So I will write 9 here and 5 here. I hope I've not made any calculation mistakes. Okay. X. Okay. And equal to, what was the gradient of the normal? Minus 9 over 10. And y. This is the equation of the normal. But equation of normal was not asked. We did so to find the coordinates of Q. And they said that x plus y plus 11, this is intersecting with this normal at Q. So do you agree that the y coordinate of this line and this line, y coordinate will be same? So what will I do? I'll convert this equation to y equal to 11 minus x, and here also that normal will become y equal to minus 9 over 10 x minus 5 plus 9. Now this y and this y are same at q. So at q, y's will be same. So 11 minus x will be same as minus 9 over 10 x minus 5 plus 9. And now we have to find x from this, and the best way is to get rid of this 10 first. I'll multiply the whole equation by 10. So 10 times 11 is 110. 10 minus x minus 10x. So we can multiply by the same number the whole equation. 10 times minus 9 over 10 will be 10 and 10 cancel, minus 9. And minus 9 times x, only this 10 will cancel, okay? Rest everything is multiplying, they will remain. Minus 9 times minus 5, positive 45. And 10 times 9 will be 90. It is not part of 9 over 10 x minus 5. 9 is not part of it. So 9 will be multiplied separately. Alright. So let's correct x's on one side. This 9 goes to the other side. So we'll add 9x minus 10x equal to 110 will be negative, right? So today 135. 135 positive minus, okay. And this will become minus 110. So minus x equal to 25. It means x is equal to minus 25. So the coordinate, x coordinate of this is minus 25. We can find the y coordinate also. X coordinate is this. So we can use y equal to 11 minus x in this. So 11 minus minus 25 will be positive 36. So these are the coordinates of q. Now we have to find the coordinates of r, right? So since 5, 9 is the midpoint of these two, that means 5 lies between a and minus 25. What is the formula? Let me use the right side here. What is the formula for the midpoint of any between any two points? It is x1 plus x2 divided by 2 equal to midpoint x, right? So midpoint is 5, so 5, let's write here. x1 is minus 25, and I have assumed that the x coordinate of r is a divided by 2. So what does it comes? 5 times 2 is 10. A is 10 plus 25. Yeah, this 25 goes to the other side, becomes plus. So it will be 35. So A is 35. What about B? It is B plus 36 divided by 2 is 9. So 2 times 10 is 18. B is 18 minus 36 minus 18. So the coordinates of R are 35 and minus 18. Question 11. In the diagram, vector OA is denoted by A and OB as B. So this is B, this is A. The point M is midpoint of OB. That means this particular length from O to M, this vector and the magnitude of MB are equal. That means this is half A and this is also half of, not A, B. Half of B and this is also half of B. Alright, the point N is such that ON is 3 times NA. ON is 3 times NA. That means if this is 3 parts, this is 1 parts. Or I can say this is 3/4 of A. Yeah, this was OA is A. This is 1/4 of A. this vector. Okay. Line BN and AM intersect at point X here. Okay. Bx is lambda Bn. So Bn is here Bn. So it is smaller than this. Okay. So Bx. Mx is this. Find Ox in terms of A, B and lambda. Ox is this one. This is vector Ox. So if I'm starting from here, this is tail. How can I reach at X? I will reach either by this route, go to N and then go to X, or go to OM and then MX. So since MX is given, I'll take this route. So from, let me write here, OX is OM, vector OM plus MX. Okay, and mx is mu times ma. Mx is mu times ma. That means this mx can be replaced by mu ma. But first we should know what is ma. So let me write here ma. Okay, m to a. I will go to O first, so mo. Then from O to A. And we know that MO is negative half B because it's the opposite direction, not in this direction. Opposite. Half B is in OM, so MO will be negative half B. OA is A. So now I can choose, write it here. So OX is OM, which is OM is half B plus mu times mx, which is ma. Sorry, mu times ma. Ma is minus half b plus a. Okay, so we got Ox in terms of b, a and mu. This is the, okay, I did this second part. I did not do this. I did the next part. My apologies, but next they are asking find Ox in terms of a, b and mu, and that I have done already. So I will do the opposite one, the first one first now, which is Ox in terms of a, b and lambda. So I have to use this one. Okay, so I'll use the other one. So Ox can also be written as, they want Bn. Bn is, where is Bn? This is Bn. Okay, so I'll go from O to B and then Bx. Alright, so OB, and they have already given that Bx is lambda times Bn. Okay, but Bn is not known to us. Bn. So to starting from B and reaching to N, I can go this way. I will go to BO. So let me write here Bn equal to BO and then On. Okay, but if you see here, Bn can also be written as BO is minus B. Yeah, B in opposite direction, B to O, and On is 3/4 of A plus 3/4 of A, BO and On, right? And now we'll substitute that Bn which we just got here. So Ox is OB is positive B plus Bx, which is lambda Bn, and Bn we just found out, which is minus B. Can you see how many layers are there on this? So Ox is in terms of B, A and lambda 2. So this is Ox, this is Ox. Next part, they have given two parts, right? A part says this, B part says this, and definitely the C part will say that find the value of lambda and mu. So I will do it here. Okay, so this is OX half B plus mu minus half B plus A equal to same OX is B plus lambda minus B plus 3/4 of A. Yeah, so I got OX equation from both sides and equated them. Let's take the B is common here now. This B and this B I'll take common, so half B is here, half B is here also. But this half B is being multiplied by mu and it's negative. So if I take half B common, nothing is left here, so I'll write 1. But this B will give me minus mu. If you think wisely, this mu will multiply with minus half B and half B is taken common, so minus mu is left. Now I'm left with A and mu. So I will write that here, mu A. Equal to same thing I'll do here. I'll take B common. So nothing is left here, so 1. But here minus lambda is left. I'll add minus lambda. Here plus lambda will also multiply with 3/4 of A. Right? Now lambda and mu are constants, whereas A and B are vectors. And the rule of vectors says that if the direction of A is this way and direction of B is this way, they cannot be converted or they cannot become scalar multiples of each other. Only A can become a multiple of A and B can become a multiple of B. So that's what we'll do now. Because B is here and B is here, and both sides will equate their coefficients. So what is the coefficient of B in this side? 1 minus lambda. What is the coefficient of B in this side? Half 1 minus lambda. Not 1 minus lambda, it's 1 minus mu. Alright? This is one equation. Second equation, if I compare the coefficients of A, mu is on one side and 3/4 of lambda is on other side. And these become our two equations, simultaneous equations. I will substitute this number 2 equation in number 1 equation. I'll substitute this mu by 3/4 of lambda and hopefully I'll get lambda. So half 1 minus 3/4 of lambda is equal to 1 minus lambda. So this becomes half minus 3/8 of lambda. Yeah, half minus 3/8 of lambda equal to 1 minus lambda. So I'll bring lambda to the other side. So lambda minus 3/8 of lambda is 1 minus half. Let's complete here. This is 5/8. 5/8 lambda is equal to 1 minus half is half. So lambda becomes half times 8/5, 4/5. So we got lambda. Now for mu, I use this equation. Mu is 3/4 of lambda. Lambda is 4/5. Mu is 3/5. So I got the values of lambda as well as mu. Done. Question number 12. We rarely see 12 questions in an exam, but here they are. We have to differentiate this particular function, and we can see that x is multiplying with another part which has a variable x. So that means we'll use product rule in this case. So dy over dx, what does the product rule say? That differentiate one part, let me call it prime here, and e to the power 3x plus 2. Don't touch it, just keep it what it is. But in second part, keep the one part same, the one you differentiated earlier, keep it same, but differentiate the other part. This is product rule. So the differentiation of x is just 1, so I'm not going to write it. I'll just write 3x plus e to the power 3x plus 2. And x, I have to differentiate this now. Any exponential part like this, we have to just copy it first and then multiply by the differentiation of the power. Differentiation of 3x plus 2 is 3. So it comes, if I take e to the power 3x plus 2 common, nothing is left in the first part, so 1 plus 3x is left in the second part, found dy over dx, this is the one. Okay, second part says, hence find the integration of x 3x plus 2 dx. Can I rewrite like this? Dy I leave here, only dy. I'll write the one which I differentiated on the other side. E to the power 3x plus 2 plus x e to the power 3x plus 2. Rather 3 was also there, yeah, this 3x. I rewrote this. This dx I can write on the other side. I cross multiplied basically. And now what will I do? I will integrate them. So the integration of dy is y. Integration of e to the power 3x plus 2 is, we again copy because it's a linear exponent, we just copy it. In place of multiplying, we divide in integration. Okay, then integration of this, I will not do anything. I'll just leave it like this, 3x e to the power 3x plus 2 and dx. Okay, and now what can I do? Because this is the question, if you remember, this is the question. Can you see it is matching exactly like this? Only 3 is extra here, right? So I'll take care of that later. So I will rewrite it now. Y minus e to the power 3x plus 2 over 3. So I removed this to the other side, equal to, I'll write this 3 outside, and x e to the power 3x plus 2 dx. Okay, now this 3 must go because our question is not that. So I'll cross multiply here, so it will become 1/3 on the other side, and this goes here, this multiplies with this. So integration of x e to the power 3x plus 2 dx is equal to 1 over 3 y, and y is known to us, which is again x e 3x plus 2. So this y is replaced minus 1 over 9, because 1 over 3 times 1 over 3, 9, e to the power 3x plus 2 and plus c, because it's an integration, I can like this way. So this concludes our solution video. If you liked it, please give it a thumbs up and subscribe to Math United. Thank you very much for your time.